Welcome to the session on classes and objects. This is going to be our objective for today. We will be learning number 1, why object-oriented programming, modeling objects, defining classes and objects in C#, and some good programming practices which we need to follow when defining objects and classes. Okay, before we proceed further, we need to understand the importance of this question, why. Throughout our module and the rest of our learning, we will focus on one important question, the why. Why are we learning this, for example? Okay, so let us start with the very first question. Why are we here together? Obvious reason, we want to learn C# programming. Okay, now to our second question. Why do we write programs, be it any language or technology? Take a moment, think. We write programs to solve problems. Programmers are problem solvers, and the more problems you solve, the more money you make. Okay, so here's a little secret for you. If you want to make a lot of money, solve a lot of problems. Okay, and believe me, programmers are real problem solvers, which we'll see in the coming lessons. So, how do we solve real world problems? Okay, yes. Take a minute, guess. We solve real world problems by modeling the real world entities in our programs and thus providing the solutions. We cannot control real world entities, but we can control the model in our programs. Okay. So what is all this about modeling, and how do we model the real world entities in our programs? Let us look at an example. So let us take the example of a college information system. Let us imagine we are writing a program to solve the problems of associated with the college administration. Take any college that you know nearby. Okay. Assume that we have been contracted by the college administration to write a program to solve the administrative problems. Okay. Now, can you go and control the student in the college? Can you go and control the staff members, the teachers, the different libraries, the infrastructure in the college? No, it's very hard, right? So what we do is we model those entities in our programs and control them within our program. Okay. By doing real world modeling, a real world entity is mapped to an object, and an object in the programming language, like its corresponding real world entity, will have state and behavior. Okay, let's understand this more carefully. Let us imagine that we are modeling a student in a program. Okay, for a student, to model a student, we need to have a student class. This student class will now represent the real world entity called student. Okay, now we said a real world entity has state and behavior, right? So for this student class, what would be its attributes and what would be its behavior? The class student is made up of properties and methods. So the attributes for the real world entity which we are modeling in our program, in this case the example is the student, the attributes would be the properties of the student, and the behavior would correspond to the methods. Okay, to explain this further, a student would have a name, they would have a particular age, and they would have an admission number, right? So the name, age and admission number are attributes of the student. Every student would have a name, every student would have an age, and every student would have an admission number. Okay, so the name, age and admission number denote the attributes of this entity called student. Okay, now let's come talk about the behavior. Students have behavior, right? They do things a certain way. They write exams, they go to the library, they read books, etc., etc. And the behavior aspects of the entity are defined as the methods. You would have a method which says write exams. You would have a method which says go to library. Okay, you will have a method which says do assignments. So I hope you understand clearly that when we model real world entities in our program, we do it for a particular reason. The reason is to solve the problem using these modeled entities. We cannot go into the real world and solve the problem. So we take a subset of it, model them in our programs, and actually provide real working solutions. So every class will represent an entity, and an entity has attributes and behavior. Attributes are the properties and behavior are the methods of the class. Okay. Now, we saw a student has some attributes like name, age and admission number. Now, how do we access and change the value of the attributes? Remember, whenever you declare a class, the attributes as a good programming practice are always recommended to be private. Okay, the name should be private, the age should be private, and the admission number should also be private. Okay, so if we have private variables, how do we access the attributes? We do this using properties in C#. Okay, so in order to allow for public access that will set the value of an attribute or fetch the value of an attribute, we need to follow a particular programming convention. For example, look at this attribute called name. Let's go back to the previous slide. So we follow a particular coding convention. If you look at the previous slide, we had name as an attribute. Okay, so if you look here, the name was started with a small letter NAME, and the property here we are defining has the same name, but it starts with a capital. The first word letter is a capital. Okay, and there are two methods in between inside, which is a get and a set. Okay, so get will give the value in the variable called name, and set will set the value to the variable which is denoted by this dot name. Okay, similarly for age we have a get and a set. To declare a property, what you need to do is write the property type, either string or an A or int, and the name followed by a pair of braces. Within the braces we may declare the get and set accessor methods. Okay, so we look at attributes, and then we define the attributes as private, type string, and name is the name of the attribute. Okay, similarly we had a private attribute of type int denoting the age, and a private attribute of type int denoting the admission number. Then we allow for public access using a specialized structure called the property in C#. Okay, we define the property type and define the name. We have a set of curly braces, and within the braces we have the get and the set values. So why do we do this? Why do we have this specialized access structure for the attributes? Okay, it is this specialized access structure for attributes allows us to enforce some validations of the data using the get and set methods of the properties. For example, let's say you have this property called age, and then you don't want the users to accidentally or intentionally or unintentionally set the value more than 100. Okay, you want to enforce that this age is always less than 100. So what you could do is, in the set accessor, you can say if value is less than 99, accept the value, otherwise set it to 0. The set accessor sets the value of a property. The value keyword is used to represent the argument whose value is passed to it and stored by the property. Okay, so this specialized structure for properties in C# allows you to enforce some validations on the data. So in general, it's always a good practice whenever you're declaring attributes to declare them privately and then allow for public access using properties, C# properties. Okay, now let's create instances of object. How do you create an instance of an object? Okay, using a new keyword. Here I say student S1 equal to new student, student S2 equal to new student, and since we declared name, age and admission number previously as properties, we say S1.name equal to Harry Potter, S1.age equal to 18, and S1.admission number equal to 123. Remember, name, age and admission number are attributes. Okay, and the way we are setting these values is using the properties we defined previously. For example, we use this public string name to set the name as Harry Potter, public int age, the set method, to set the value of Harry Potter to 18, and we made sure the age is less than 99 for Harry Potter. Okay. Similarly, we did it for a new student called Ron Weasley. Okay. So S1 and S2 are two student objects, and we create the objects using the new keyword. Okay. Now that we have two objects, S1 and S2, and both represent students, let us try and answer the following questions. What is the type of S1? What is the type of S2? What is the state of S1? And what is the state of S2? Okay, we have S1 and S2 as objects. We set the name, age, admission number for S1, and we set the name, age, admission number for S2. Now the question is, what is the type of S1 and what is the type of S2? What is the state of S1 and what is the state of S2? Type is the class to which an object belongs to. For example, S1 belongs to the type student and S2 belongs to the type student, because S1 equal to new student and S2 is also equal to new student. Okay. State is the value of the attributes for a given object. S1 and S2 have the same type but different states. Okay. S1 denotes Harry Potter while S2 denotes his pal Ron Weasley. Okay. Both S1 and S2 belong to the same type but have different state. So please remember to make this differentiation. An object has a type and a state. Type is the class to which the object belongs to, and state is the value of the attributes for a given object. Okay. Now we can print the object state using the normal console.writeLine method. Okay, writeLine method. Okay. So let's say in our example we have console.writeLine and we say S1, and then we have console.writeLine and say S2. Remember, S1 and S2 are the objects of type student. S1 was Harry Potter and S2 was Ron Weasley. Now if you look at the output, it says console application 1.student and console application 1.student. This does not seem to be meaningful, right? In order to have meaningful output, we need to implement the toString method. So in your student.cs class, add this method public override string to string and print the state of the object. Okay, So in general, it is a recommended good practice to always print the state of the object in the toString method. Okay. Now let's say you wrote this method toString in the student.cs class. Now execute the program once again and you will see the difference. Okay. Let me bring up Visual Studio and then I say File, New Project. I choose Console Application, say OK. So this builds a application template for me. Okay. So on Solution Explorer on my left, I select the Console Application 1, which is the name of my project for now. Okay. And then I say, I right click it, I select the Console Application 1, I right click it, and then there is this thing called Add. I select the Add menu and I say select New, Add New Class. Okay, so I change name of the class to, I'm going to do model a student here, so I'll say this student.cs and I'll say add. Okay, so you see student.cs listed in the Solution Explorer. Okay, double click it to bring it up in your editor and say private string name, private int age, private int admission number. Okay, now let's save this and let me also add the properties. Okay, so I added the properties, name, age and admission number. Okay, now let me go to the program.cs and create the student objects. Student s1 equal to new student, s1 dot name, is a name here, equal to Harry Potter. Okay, s1 dot age, I would say is 18. s1 dot admission number, let me say is 123. Okay, now let me do the same thing again for another student. Okay, s equal to new student and I say it is Ron Weasley. Okay, and the admission number current will be the same, I make it 1 to 4. Okay, now I say console dot write line s1. Okay, and then I say console dot write line s2. Okay, let's print it. Let's print the output to the console and then wait for the read key so that we get a chance to look at the output. Okay, so I save this one. Okay, and then I'm going to run this application. Click on this green button. Okay, the output says it is console application 1.student and console application 1.student. Does it make sense, right? Okay, so let's end this program. And we know about the object has a type, object has a state. Let's print the state of the object. Let me open up student.cs and then here I written the toString method. Now I save it again and then when I execute the program, I get the output as something else. Okay, sorry, there's a problem in the code. It should be S2. Okay, let me end this program. S2.name, S2.age, S2.124. Okay, so we have student S1 and S2, and we're printing the objects S1 and S2. What we have done here is we have attributes which are private and public properties, and then we have also added the toString method to print the state of the object. Okay, so let's run this, save this, and let's run this application. Now we can see the output as name is equal to Harry Potter, age is 18, and admission number is 123. Similarly for Ron Weasley. So so you can see very well that it makes sense to print the state of the object in the toString method. Okay, so you have learned something very important today, right? As a good practice, you should always implement the toString method in your class, and in the toString method you print the state of the object. Remember type and remember state. Okay, toString method always prints the state of the object. Okay, let's continue with the learning. Now let's look at object equality. How do we say two objects are equal? C# uses the equals method to determine if two objects are the same. For example, let us assume we have S1 and S2 as two new student objects, and S1 is Harry Potter, S1 age is also 18, and S1's admission number is 1 to 3. Okay, and S2's name also is Harry Potter, S2's age is also 18, and admission number is also the same. Okay, so S1 and S2 have the same state. Okay. Now if I write something like this, if S1 equals S2, if both S1 and S2 are equal, I want to print the line objects are the same. If S1 and S2 are not equal, I want to print the line objects are not the same. But when I run this program, C# tells me objects are not the same. How come? To understand how object equality comparison is done, we need to understand the heap memory. Okay, heap is an area in the memory, generally in the RAM. Okay, and when you say I create a new object called S1, what the compiler does, or the operating system does, is allocates a memory area on the heap and gives your program a handle to it. Okay, so when we say S1 and S2 are two different objects, and they both point to an area on the heap. Heap is just memory. Assume for now heap is a area on the memory. Okay, and you have a handle to that area through S1 and S2 variables. Okay, all right. Okay, now here what we did is we have S1, S2, Harry Potter, both have the same state, and then also we say S3 equal to S1. Okay, now in this example, both S1 and S3 point to the same object, and S2 points to a different object. Even though the object states are the same, the S1 and S2 are two distinct references because they use the new keyword here. Okay, please get this point across. It's very simple. Okay, whenever you use the keyword new, you have a new object reference. You have a separate distinct reference. Okay, so take a minute to study this chart, and S1 and S2, though both have the same state, point to two different areas in memory, and since S1 is just assign S3. S3 is like an alias to S1. Okay, so you can refer to the object 1 area either through S1 or through S3. Okay, so in the absence of the equals method in your program, like how we have now, C# simply does reference checking to check for equality. If references are different, then the objects are not equal, though they have the same state. Okay, so in our case, S1 and S2 had the same state, but both had the new keyword to create an object. So S1 was a new reference and S2 was a separate reference. So even though the states are same, the objects are not equal according to C#. Okay, whenever you create an object with a new keyword, for example, student S1 equal to new student, the CLR allocates memory on the heap and gives you a handle or reference to that memory location. S1 and S2 are references to two distinct memory locations on the heap. So even though S1 and S2 are the same state, the references are different. That is why C# considers them to be different and not equal. So how to fix the problem? Let us implement the equals method using the object state. Okay. Here is the equals method. The signature is public override bool equals object obj. Okay, and what we first do is we first check if the references are same. If the object being compared and the object where the comparison is being done point the same reference, then they are true. For example, S3 and S1 point to the same object reference. So if you say S3 equals S1 or S1 equals S3, since both references are the same, you immediately return back as true. So let's assume the references are not the same. Okay, let's assume we're comparing S1 and S2, which are created with a new keyword. S1 equal to new student, S2 equal to new student. Now references are not the same, so we go to the second check. We check as a type. If the object which is being compared S1 and the object which is on which a comparison is being made S2 belong to the same type, then we continue. If the types are different, we can't compare apples to oranges. Okay, if the types are different, we just return false. They cannot be the same. Simple. First we check for references, then we check for type. Okay, so let's assume types are equal. Both are student objects. Then we look at the attributes. We check here in our example, we are taking name. If both the names match, we return true. Otherwise, return false. Okay, so this is a simple implementation of the equals method. Okay, in this example, again, we are reiterating again. S1 and S2 are two new students having the same state. Okay, and S3 is an alias to S1. So now, since we have an equals method, our equality check is based on object state. Okay, so let's do a quick demo. Okay, here am I at the C# IDE Visual Studio. I go to the program.cs. Okay, and then I write the comparison code. So I'm comparing S1 and S2 using the equals method. S1 is, in this example, is Harry Potter. S2 is Ron Weasley. I expect to say objects are not equal. Then I create a student called S3. Okay, using a new keyword, and I specify the name, age, and admission number to be the same as the state of S1. Okay, so S1 and S3 have the same state. Now I compare S1 and S3, and I expect the program to print objects are equal because they have the same state. Okay, so let's run this program and see. Look at the output. Save this. Click on the green button here, which is start debugging. It compares objects 1 and 2 and says the object is not equal, which is right because one is Harry Potter, the other is Ron Weasley. Okay. Now when it compares objects 1 and 3, it still says objects are not equal, even though S1 and S3 have the same state. Okay, so let's fix this by implementing the toString method, equals method. Okay, here am I back at Visual Studio Express, and then go back to open the student.cs class and just write code to implement the equals method. Okay, so here's the equals method. We first compare the object references. If references are the same, then the objects are equal. Okay, then we check the types. If the types are different, we blindly say that they are not equal. And if the types are the same, then we look at the object state. Okay, that's all, nothing else, right? Just save the student class and then run it again. Now when it compares 1 and 3, it says objects are equal. Good, isn't it? Okay, this is what we expected. Okay, let's go back. Okay, so we saw the implementation of the equals method. One important concept which we need to understand is the hash code. Okay, every object has a hash code. A hash code is simply an integer representation of the state of the object. A hash code for a given object is guaranteed to be unique within a CLR instance. Okay, the C# language mandates that if two objects are the same, then the hash code should also be the same. Okay, if two objects are the same, then the hash code should also be the same. In order to honor this commitment, whenever we implement the equals method, we also need to implement the getHashCode method. Let this sink into you. If two objects are the same, then the hash code should also be the same. Okay, this is a law which is mandated by the C# language. Okay, so how to implement the getHashCode method? An easy way of implementing the getHashCode method is to use the getHashCode from that value in the object is guaranteed to be unique. In our example of a student object, it is the admission number which is going to be unique. We can have duplicate names, we can have duplicate ages, we can even have duplicate date of birth. But the admission number in this context of a solution, which is a college administrative system which you're developing, is guaranteed to be unique. So we say add this method public override int getHashCode, and we just return the admission numbers dot hashcode. Okay, so it's a very simple implementation. Okay, so let's understand what is a business key. A business key is that value in the state of the object which will be unique for all the objects. The business key is like the primary key then when you compare it to the database analogy. Remember, the business key is different for different applications. For a banking application, for example, the account number could be the business key because the account number is guaranteed to be unique across the customers, right? And for branches, the branch number may be the business key. For telecom application, the mobile number may be the business key. For a government application, the UDID or the social security number may be the business key. In our case, the college administrative system, the admission number is the most likely candidate to be the business key. Okay, so let's look at a C# program to complete the getHashCode method. So the getHashCode method, the signature is public override int getHashCode method, and since our business key is the admission number, we print the hash code of the admission number. Okay, so what have we learned so far? We have seen how and why we need to model real world entities. Okay, to solve problems you need to model the entities into your program, and how we do it is use each entity will correspond to a class, and an entity has attributes and behavior, and your class has properties and methods. Okay, we understand the following: why we need to understand what is real world modeling and why we define classes. We saw how to define a class in C#. An object is an instance of a class. S1, S2, S3 were all student objects of type student. We also saw the difference between a type and a state of an object. We also seen why we need to implement the toString method. Because if you don't implement the toString method, the output from the write line method is meaningless. So this will help you a lot while debugging your programs in real time. So as a good practice, always implement the toString method. We also saw how to implement the equals method. In the absence of overriding the equals method, C# uses just the reference checking for equality. We also looked at the memory management. We saw what is a heap and how objects are allocated on the heap. Okay, and how references are, how the object references are handles to the actual memory location on the heap. We also saw how to implement equals method. We first do reference checking, then we look at the types, and only the types match. We look at the state of the object to do equality comparisons. We saw what is a hash code, and we saw why we need to implement the get hash code method while overriding the equals method. For now, we just saw that it is managed with the language. That is what we learned. But the implications of it we will see when you go to collections. Okay, how to implement get hash code method? Generally, it is the hash code of the business key. What is meant by type? You should be able to answer all this following, right? What is meant by type of an object? What is meant by state of an object? What is meant by hash code of an object? Why do we need to implement the equals method? What is the rule we need to comply with when implementing the equals method? And explain why we need to implement the toString method, and what would be the behavior if we don't have a toString method. I hope you enjoyed these lessons. We'll see you soon.